Hello and welcome to a new video on YouTube channel of tutorialspedia.com. This video is part of a series of MuleSoft video tutorials, and we are going to cover transactions in this video, and we will see that how we can use database local transactions in Mule4. Let's look at the topics that we are going to cover in this video tutorial. This tutorial is in two parts. In first part we will have some theoretical concepts explained, and then in the second part of this video we will be having a demonstration. So the topics to be covered in this video tutorial include MuleSoft Transaction Overview, where we will have a high-level overview of what exactly transactions are, and we will see that what are transactions and why we use transaction and what is the purpose and benefit of using the transactions. Then we will see what are the different transaction types in Mule4, and then we will talk about actions, transaction actions that are available in Mule4. And last but not least, we will have a local transactions demo for the database transactions in a project that we will be having in Anypoint Studio. So let's first have a look at transactions basic concepts and a high-level overview. A transaction consists of one or more operations as an atomic unit to be treated together. So what happens is that whenever you are implementing your projects, whenever you are creating your message flows, there are certain type of operations for which you want that either all of them should be committed together, or in case of any issues or any errors, entire group of operations should be rolled back. For example, maybe you are doing some operations on different tables in the database, and you don't want that some of those DML operations are committed and some of them are incomplete or in error. So you want either entire group of actions should be committed or rolled back to make sure that the data that is available in the database is in the correct and consistent state. And the purpose of transaction management, as I explained, is to ensure that we have data consistency and there are no data anomalies and there is no mismatch in the data. For example, maybe you are having some transactions which are updating one of the table, and at the same time some other actions are being performed on other tables. You don't want that some actions get completed on one of the table, but on the other table the required actions are not completed. So example that we take in this case is a banking scenario of balance transfer from one account to another. This is not the real scenario. In the real scenario, there might be some difference of action, but in general, let's take this example that we have a sender account and we have a receiver account. So normally what happens is that whenever transaction is made within a bank from one account to another account, then sender account is debited and the receiver account is credited. So in this case, we let's consider another action that a transaction notification is sent. So what we want in this case is that whenever such a transaction is made, all of the three operations should be completed. That is, sender's account should get debited, and the amount that has been transferred from the sender account should get credited into the receiver account, and at the same time a notification should be sent informing about the transactions. So what we want is that all of the three operations in this example scenario should be committed together or rolled back. We don't want that sender's account gets debited, but for any reason receiver account doesn't get credited, or we don't want that for any reason there is no debit update happening in the sender account, but there is a credit on the receiver account. In both cases there is a mismatch in the balance. And also we don't want that transaction gets happen and there is no notification sent. So in this case, this is one of the example scenario where we will be looking for the transaction management, and we will be implementing our solution in such a way that all of the operations should be completed as a single logical unit with entire units commit or rollback. So either all of the operations should be completed or none of them should be committed. Okay, so now we have explained the high-level overview of what exactly transactions are. Let's talk about transaction types which are available in Mule4. So if we talk about supported transaction types in Mule4, there are basically two types of transactions which are supported: local transactions and extended transaction or XA transactions. Local transactions are also known as single resource transactions. So in this case, what happens is that whatever transactions you are performing are on a single resource. For example, you might have one single database connection. So all of the transactions that are happening are on different tables for the same connection. So in this case, it's not only database; it can be JMS, it can be VM as well. And in case of extended architecture, this is in this type of transactions, you can have multiple resources, and this is called two-phase commit transactions. So in case of exit transactions, as I mentioned, it's two-phase commit. So what happens is that underlying architecture of exit transaction is in such a way that commits take place first in the persistent storage, and then in the second phase, the actual commit into the underlying database or JMS or whatever type of module we are using takes place over there. So this is in case of exit transaction, we use some sort of transaction manager. But in this typical example demonstration that I will be covering in this video tutorial, we will be focusing more on the local transactions instead of exit transactions. And if we talk about the modules or connectors which support the transactions in Mule 4, basically there are three types of modules or connectors for which you can utilize this transaction management, which includes JMS, database, and VM. So these for these three connectors and different operations within these connectors, you can use transactions and you can achieve the transaction management. Now let's talk about MuleSoft transactional actions. So when we talk about transactional actions, there are different actions which are having different scopes. For example, some of them are applicable to try scope, and some of them are applicable to listeners, and some of them are applicable to some specific supported operations. So if we talk about one always begin, so this type of transactional action is applicable on the supported listeners as well as on the try scope. Whenever you are creating your project, as we will see in the demonstration as well, that in the message flow, when you create a try scope, you have an option to specify what kind of transaction action you want. So when you select always begin, this means that whenever the flow will reach to that particular point, be it a supported listener or be it a try scope. So this is going to start a new transaction. So in case of local transaction, it's going to create a new transaction. But if a transaction is already there, of course, in that case, it will throw an error because it's not an exit transaction. And in local, there can be only one transaction at a time. And then the second option is to choose always join, and this is for the supported operations. For example, you might have some database operation or JMS operation. So for that, in the advanced configuration of that operation, you will select this always join. So there is a typo. Instead of join, I have mentioned join. So just consider it as join. So in case of always join, what will happen is that if a transaction is already there, it's going to join. And if there is no transaction, then it's not going to join. It's going to throw an error. And the third scenario is begin or join. So this is for the try scope. So in this case, what will happen is that if we select this transactional action for the try scope, then it's going to start a new transaction. And if there is already a transaction, it's going to join the existing transaction. So in this case, from the try scope, it will not throw any error if there is already a transaction, rather it will join. And if there is no transaction already in place, then it's going to create a new transaction. And then for the supported operations, there is another transaction action join if possible. So in this case, this particular operation where you are specifying this transactional action, it will try to join. And if it's able to join, it will join. Otherwise, the processing of that operation will continue without joining the transaction. So it's a loose style of transaction management in this case, where you are choosing join if possible. And then indifferent, this is the default action for the try scope, and but in this case, it doesn't care about it. And then there is another transaction action which is none, and this is applicable for the supported listeners. So in case of supported listeners, you specify if you specify none, then it's not going to take any action related to the transactions. And then not supported, it is for certain operations which are actually supporting the transaction. But if you select not supported, then that particular operation for which you selected not supported will be considered out of the support for the transaction. So it will not be taking part into the transaction. So now that I have explained at a high level what are different transaction types and what are the transactional actions, it's time for a demo where we are going to look into the things in action with a project already implemented in Anypad Studio. All right. To save some of the time and to keep things manageable easily, what I have done is that instead of creating the entire project and adding all of the operations and everything side by side, what I have done is that I have created the project already, and this is the project with the name transaction test. And in this, we have already a message flow with the name transaction test flow. And you can see here that what I have done is that I have added a listener so that it starts with a HTTP request. And once it receives a request, let me show you what exactly the listener configuration is. So I just put /abc and just a dummy path for this HTTP listener. And this HTTP listener is listening on the port 8081 with the local host. And then what happens is that once it receives the request, so I'm picking one of the query parameter attributes.queryparams.order id. So whatever order id will be passed in the query parameter, it will be saved into this order id variable. So I'm saving that request query parameter order id into a variable, and after that I'm starting a try scope. So in the try scope, if you see here in the transactional action, I'm selecting always begin. So it means that once the flow will reach to this try scope, it's going to create a new transaction. And the type of transaction I have selected is local. So we have two options, XA and local. So instead of extended, I'm choosing local, which is the default transaction type. After that, if you see here, I'm inserting into two tables. So I'm connecting to MySQL database. Let me show you the connection. So I'm connecting to localhost 3306, where one of the database instance is running in my local machine. And the name of the database, I have named it as Tutorialspedia. And then what happens is that inside this I'm adding I'm inserting into the table. So I'm inserting first into a table with the name orders, and I'm passing order id, order item, order quantity, order status. In the values that I'm passing, let me show you. Values, I'm passing id, which is the order id which has been passed as a query parameter and saved into the variable. And then I'm just hard coding other values. For the order item, I'm specifying a laptop, and quantity 5, and order status as recorded. So this is just dummy information that I'm inserting into the table. And at the same time, within the same transaction, I'm adding into another table, which is the name, which is insert into notifications. So if you see here in the notifications, I'm adding notification ID, notification order reference, notification message. And the notification ID and notification and order ID, I'm passing same value, which I have saved into the order ID variable. So basically, notification ID and order ID will be always matching to whatever ID has been passed in the query parameter, and order is recorded. So this is the information that I'm adding into this notification. So before I go to this transform message, so here what I'm going to do is that I'm going to create some error. If you see here, I'm doing number equal to 1 divided by 0, so it's going to throw an error. That's what I want to see. So if you go to this first insert statement, and if you go to advanced, you can see I have selected always join. So this means that what will happen is that since transaction will begin with the try scope, as we have selected always begin. So once it reaches to the insert statement over here, it's going to join. So this operation in this insert operation is going to join the transaction. So it will be part of the transaction. If you see the second insert, and if we go to advanced, we have selected not supported. Intentionally, I have selected not supported, which means that this notification is not going to be the part of transaction. So whatever happens to the transaction, this particular insert into the notification will be executed independently. So it will not cause a rollback or commit for this particular insertion based on the entire transaction, and it will be executing out of the transaction scope. And once it goes to this, so what will happen, it will insert first into the table, order table, and after that it will insert into the notification table. And now if anything goes wrong here, so of course it will go wrong because it's 1 by 0, so it's division by 0, so it's going to cause an error. So what will happen is that the first transaction, which is part of the transaction, will fail, and the second transaction, which is set to not supported in our transaction action, it will be still committed. So this is the first case that we want to showcase. So let me now try to show you the tables that we have. If we go here in the database, we have two tables. We have orders tables. If I see right now, it's blank, it has nothing. And we have notification table, and this one is also blank. So now once I will execute this message flow, as I explained, this insertion should fail because of the failure in the transform message, but this insertion into the notification table should get successfully completed. So this is the first scenario that we are going to see. Later we are going to play around with other different actions and see how it behaves. Okay, so let me run the project first. So I'm going to run this project, and then we will try to hit the service. It will take a little time to get loaded, and once it's running into the runtime, then we will be hitting the service. Alright, so we can see that the project status is now deployed. This means that project is running fine in the embedded runtime. Now I'm going to hit the service. So what I'm going to do is that I'm going to use browser and choose localhost :8081/abc (order ID). So we have to pass a query parameter for the order ID. So let's try to send it with the order ID as 1 and see what happens. So you can see that here we have got a response division by 0, and this is the error, and this is an expected error as we did division by 0 in this transform message. So now what I'm going to see, what I'm going to do is that we are going to observe from the database, and ideally as we selected the different transaction actions, there should not be any record added into the orders table, and yes, we can verify there is nothing. And if we go into the notification table, we can see that a record has been added. So the reason that it got added into the notification table in this using the second insert is that we selected the transactional action as not supported over here. So this means that this insertion happened even though we have a failure in the try scope, because this is not part of the transaction. Now what I'm going to do is that I'm going to change it to join if always join, or even if we select join if possible. In both cases, we will see that now if we try to hit this service, it's not going to insert in both of these tables. Let me save it. So once I save it, this should get loaded again, and once it is deployed again with the changes into the embedded runtime, then we will hit the service and we will see and observe what happens. So what we are expecting is that now once it gets loaded and running with a new request, it should first insert into the orders table, then into the notification table. But once it fails in the transform message, which is within the try scope, then it should roll back both insert. So it should not insert into orders table, as well as it should not insert into the notification table, which means that it should be rolled back from both of those tables. So let me go to the client and let me try with the order ID as 2, and we got the same error division by 0. And now if we go into the table, if you see in the orders table, there should be nothing inserted. Yeah, there is nothing inserted. And if we go to the notification table, here also there is a previous insertion with the order ID 1, but the new one that we did with the order ID 2 is not inserted, because now we have added both of these insert operations with the transaction action as always join. Now, if I try to correct it, I mean, if make any changes in this transform message to something which is acceptable and which doesn't throw an error. So now its number is 1 divided by 1, or just put it 1. So in this case, what will happen is that the entire group, this atomic group will be executed, and we will see that the insertion will take place in both tables. So let me save it so that it gets reloaded and redeployed. So let's wait for it to get redeployed, and then we will try to hit the service again. So now let's try to hit the service once this reloading or redeployment gets completed. Okay, so now I'm going to try it again. So we can use the same ID as order ID 2 because we didn't get any commit in the last request. So now if I try it, we got the message as done. And now if we go to the database, we should be able to see this entry in both tables. So if I go to order table, we can see that a laptop with the order ID 2 has been added. And if we go to notification, we should see another record with our ID 2. And this one is also added. So in this way, we have observed that what happens if we choose or always join, or if we choose not support. Now let's add it as join if possible. So we want to now see what will happen with join if possible, and here I'm going to make the error again. So it will be 1 divided by 0. So let's see that how it behaves with the by choosing join if possible. So the first insert is still with always join, and second insert that we are doing is with the transactional action as join if possible. So now we are going to hit the service again. Let's wait for redeployment with the changes, and then we will hit the service again, and this time we will pass order ID as 3 because with order ID 2 we have already inserted some data. So the code has been redeployed with the changes. So now let's try to hit the service. Okay, so we got the error dbn by 0, which is fine. Now we want to observe what happens into the database. So first we go to the orders table. We don't expect any entry. Yeah, there is no new entry added into this table. And let's go to the notification table. And notification table also doesn't have any new entry because it was join if possible. So it was possible. So it was because there was a transaction already there. So this operation also based on this option of join if possible, join the transaction, and once both of these operations for the first insert and second insert were part of the transaction, any failure that occurred in this activity for the transform message that has rolled back both of these. So this is how we choose this option of always begin. And even if you choose begin or join, in this case it's a local transaction and there is no other transaction on the listener because HTTP listener doesn't have any transaction. So in this case, even if you choose begin or join, it will have same impact. So if you choose this and see what happens, it should behave exactly same. So now I'm going to save it. So it since there is no existing transaction, so it's going to begin. It's not going to join a transaction. So let's wait for the redeployment, and then we will see that how it behaves. And this time we will try to hit it with another ID. Even if we try with the same, we can, but let's try with ID 4. Let's wait for the redeployment, and then we will hit the service. Okay, so now I'm going to hit the service. We should get deviant by 0, and now if we go to the database we should not see anything, any new entry. So in the notification we don't see anything, and in the orders also we don't see anything. The reason is that the action that we took has the same impact as the previous case because the only change we did is that for the try scope, instead of always begin, we selected begin or join, and in this case it has same impact. So in this way, we can play around with different actions and different transaction operations that are available, and we can observe how it behaves for different type of operations as well as for the try scope or supported listeners. So in this case, we use HTTP listener. This is not a supported listener, but if you choose some other type of listeners, for example, if you select some of the listener from the database, If you see in the database module, we have on table row. So if you choose this one, and if you want to take any actions based on any updates or any insertion into that particular table, and then you want to perform some other actions, you can use this, and this supports uh, transaction. And then in that case, you can play around with the listener or the process starter based transactions as well. You can also play around with the JMS transactions and VM transactions, as JMS and VM modules also support transaction management, and you can play around and you can observe that how it behaves. So that's it from this video tutorial covering some of the basic concepts and some of the important steps that you need to follow when you have to use transaction management, local database transaction management in Mule for projects. And I hope that the information that has been conveyed to you through this demonstration will be helpful. Of course, there is a lot more yet to be uncovered, and you can always expand it and extend it by trying more and more options, and you can always play around with different modules and different actions that are available. But whatever I have explained in this tutorial should be helpful for you to jumpstart and to understand the basic concepts and the basic and the fundamentals of MuleSoft Transaction Management. If you want to learn more, you can always refer to other videos that I have uploaded in this channel in the MuleSoft playlist on Tutorialspedia. And you can always refer to the MuleSoft official documentation. That's the most updated and the exact source of truth for any of the knowledge that you want to gain related to MuleSoft. And if you like this video, don't forget to subscribe to the channel. And if you have any questions, if you have any ambiguities, or if you have any feedback, feel free to write in the comment section. Thank you very much.